Hey guys, it's Miss Miller. Let's go ahead and get started with displacement and velocity. We're going to take this next chapter, which is on motion in one dimension, and we are going to break it up into its three sections, so you'll get 3 videos. To start out, we need to understand for this first section a few key terms. And first of all, what does one-dimensional mean? Well, that's your simplest form of motion or movement, and basically we are either moving an object. This dot is going to represent my object. It's either moving to the left or it's moving to the right along what we would call an x-axis or your horizontal axis. So that's going to be your horizontal motion or your x motion. That is one dimension. Now we say we live in a 3D, 4D world, okay? Well, your first dimension is left and right, your x-axis. Your next dimension is okay. We have vertical, so a string. A string. This would be one dimension, okay, in this direction, or we can also put the string in that direction. That's one dimension. That would be my y-axis. So if something is moving in a line up and down, then that is also one-dimensional motion. Now, we may say, okay, well, something is moving at an angle. Basically, if it's moving in a line, then it is a one-dimensional motion. Now, let's say we have something that's moving in 2 dimensions, like this paper. It's moving up and at an angle, 2 dimensions at the same time. It's changing its motion. That's what we'll talk about in a couple chapters later when we get to projectile motion. That's when we start dealing with 2-dimensional motion. That would be, we have our x-axis and our y-axis combined. Our world, we have an x-axis, we have a y-axis, but there's also a depth, so we have a z-axis as well. And then, of course, we consider time to be the 4th dimension. But I don't want to talk too much about that. We're going to just discuss one-dimensional motion today. It is the simplest, which is good. Now, motion is something that's going to take place over time. So when we talk about motion, we need to consider that there is always this clock running and changing time. Okay? We will always have some change in time to look at. We're looking at how is an object changing from T1 to T2. Or time 1 to time 2. What's going on with its motion? Is it getting faster? Is it getting slower? Is it moving to the left? Moving to the right? Is it moving at a constant speed? All of these questions are questions we ask ourselves when we talk about motion. Now, it depends on the frame of reference. Frame of reference is an important word that you need to understand. In most cases, we're going to be talking about problems with a frame of reference to the ground or the frame of reference to the floor, whatever our object is moving on. However, you need to understand that a frame of reference changes. It depends on what you're comparing it to. So let's say I'm talking about this golf ball here. Okay? In my frame of reference, if I were to look at it, I would say the golf ball isn't moving. Okay, so the golf ball compared to me is not moving. However, let's say someone's out in space, okay, or, you know, the sun has eyes suddenly and it's looking at this golf ball for some reason. It would say the golf ball is moving because we know that the earth is moving around the sun. So to the sun's frame of reference, the golf ball is moving, okay. Let's say I have this golf ball now, and I'm in a plane, okay? Well, according to me again, the ball isn't moving. It's sitting still in my hand. According to someone down on the ground looking up at the plane, the golf ball would have to be moving because the plane is moving with it. So that's what your frame of reference is. We need to make sure that we understand what are we comparing this to? And for our case, again, we're going to make it easiest by always comparing things to the floor, okay, or whatever we're moving against. So, for example, if I wanted to talk about me throwing this ball, I would say I threw it up and it came right back down. Okay. that's my frame of reference. However, according to someone out in space, it actually took this kind of path where it was moving horizontally, but it also went up and down. So it moved in 2 dimensions if we're talking about compared to space. But compared to me, I am stationary, it went up and it came back down. So maybe that'll help you a little bit with understanding frame of reference. Now, another key term we're going to just dive right in and I'm going to give you is displacement. Okay, now I'm going to assume that you've already read your outline and you understand this definition, but displacement is a change in position. Okay, change in position. I'm going to write delta x. This delta is a Greek letter and it means change. Okay, if you've ever seen delta in math, it always means that we're going to subtract things, and that's exactly what we're going to do. Displacement is taking a final position, we call x our position, minus our initial position. So here I've introduced a term, and I've also introduced a couple variables. XF is final position. Obviously the F stands for final, and X stands for your position. This is assuming that we are moving along the x-axis. Now it's very easy to then translate. Let's say we're moving along the y-axis. Our displacement would be the change in our y. So we would have YF. Okay, our first vertical position minus our second vertical position. Alright, so there's displacement. Let's say we have a football player. Here's my poorly drawn football field here. Woo. Okay, here's the 50-yard line. Guy runs the ball over here to the 20-yard line. Okay, we started at 50 yards. Oh, I don't like that. Let's say we start at the 20 yards. We're going to start at the 20 yards for some reason. The ball is moving from 20 yards to 50 yards. So, that is my initial position. This is my final position. Okay. We have 20 and 50, so what would be my change in position or my displacement? Well, delta x, my displacement, would be 50, my final, minus my initial, which is 20. So delta x would then be 30 yards, I guess, since we're talking about a football field. Notice I'm using yards in all of my examples. So there's how you find displacement. It's your final position minus your initial position. Now on a number line that can be different, and that's how we're going to look at displacement. Let's say we have, here's my number line. We have 0 meters, and then 10, 20, 30, 40. This M is for meters. 50, 60, 70, 80. Okay. Let's say we have a person, they start right here, and we are walking, and they move in the positive direction. This is my positive direction. Of course, if we were back here and that was negative 10 meters, that would be the negative direction. But if we're moving in the positive direction, and we end up right here, okay? XI, XF, initial position, final position. My delta X, change in position, is 80 meters minus, looks like 25. Okay, so we have 55 meters is my displacement. Now, what if we're moving to the left? So this person starts over here at 80 meters, and we're going to go back. We're going to go back to 25 meters over here, but now we're moving to the left. XI, XF. Okay, this is where I started for the second portion. This is where I end, okay, for the second portion. So my displacement, change in position, is going to be 25 meters minus 80 meters. So now we have a negative 55 meters. So what does that negative mean? Because that has to mean something. This is math, okay? Positive, negatives, everything is wonderful. It's meaningful. This negative means that we must be moving in an opposite direction. Or in this case, we are moving to the left. Okay, that's something you need to know. A negative displacement means you're moving to the left. That's going to be very important. Okay, now we need to understand what is the difference between distance and displacement. You might be saying, Ms. Miller, why don't you just say displacement is the distance you go? I'm either going 20 meters, 30 meters, whatever, negative 55 meters. Well, there's a bit of a problem with that because displacement is specifically defined as a change in position, whereas distance is just how far you go. Okay, and if I move, I'd like to know how far I go. Sometimes I don't care that I moved left or that I attached a direction with my motion. Okay, I just maybe want to know I ran a mile. I don't care I ran a mile in a circle or I ran a mile north, south, east, west. I don't care about the direction. And if that's the case, you're talking about distance. Now, to help you understand this, let's say, okay, here I'm sitting in a chair, all right? You can get your stopwatch out or you can use your brain and count, but I'm going to move. Okay, ready? Go. Coming back. Okay, I'm in my chair again. So, that being said, what is my displacement? Well, my displacement is 0. It's my initial position, which was on the chair, and my final position, which was in the chair. So if I take that position minus that position, I'm going to get 0. So you're telling me I didn't move at all. No, I'm telling you I didn't, or you're telling me that I didn't displace myself at all. I didn't change my position from where I started to where I ended. However, if I wanted to know the distance that I went, and by golly, I better have went somewhere because that almost seemed to be a struggle, what would I need? Well, I would need to know the amount of time that it took me to go, because remember, motion in one dimension happens over amount of time. So you timed it, and I would ultimately need to measure the path that I took. Okay? Or if I were to measure the path that I took, that would give me the distance that I went. Really, I didn't move in nice blocky steps, but a meter stick or anything that measures distance would work fairly well. So that's your difference between distance and displacement. Let's say I walked around this table and I could do about 12 of these. That means that I actually moved a distance of 12 meters. However, my displacement was 0. And just to visualize this really quick, here's my chair, here's my classroom table that I went around. Let's say this was the path that I took. Okay, well, XF and XI were the same place, so my displacement was 0. However, let's say 2 here, 2 there, and 6 here, and 1 here, and 1 here. Okay, or let's make that 4. My distance that I covered, I'm just going to label distance because we're actually not going to use distance very much in this class. None of your equations will deal with distance. They always deal with displacement. But to understand the difference, the distance would be, I went 2 meters, then I went 1 meter, so I'm at 3, then I went 4, so I'm at 7, then I went 3 more, so I'm at 10. So that's a big difference. Okay. 0 meters and 10 meters are two completely different values. So hope this helps. I'll post another video soon for